Recording started.
Hi Ma20-3 students. Hope you guys had a great Easter long weekend. And as you know, we have our midterm exam coming up fairly soon. It's going to be on April the 16th. That date should be pretty easy for me to remember. That's my mom's birthday. So anyways, let's get started with this here. So we can see the first question here, it's going to deal with taxes. And we have good old Uncle Sam here. And he's saying it's tax time. So tax time is actually April the 30th, I believe, in Canada. That's when income taxes need to be filled out. Anyway, so question number 1 here says, calculate the property tax payment for $3,480 paid weekly, rounded to the nearest dollars. So the way we make the calculation is we take the annual tax amount, that's $3,480, and we divide by 52 because there's 52 weeks in a year. And that will help us to find the weekly tax amount. Okay, so this one's pretty straightforward, right? Just calculate it by taking the yearly amount and divide by the 52 weeks of the year. Now, there are kind of different flavors of this same type of calculation. For instance, if you had a biannual tax payment, that would be dividing by 2. Twice a year you're paying taxes. Quarterly tax payment 4 times a year, so we divide by 4. Monthly by 12, and again, weekly is dividing by 52. All right, so let's go on to the next question. And the next question is going to deal with investments, and we're kind of compare the difference between investments and loans. So the question says, which of the following would not help speed the growth of an initial investment? So I'm going to underline would not help. So the initial investment is $5,000. So before we get right into this, let's just kind of contrast the difference between the principles involved in loans and mortgages and investments, because they're kind of the opposite. Now, if you're taking out a loan or a mortgage is just a special type of loan, you want a low interest rate, right? You don't want to be charging much interest on the amount that you're borrowing, so you want a low interest rate. You want a small amount of principal. Remember, the principal can be either the amount of loan borrowed or the amount of investment. So you want a small amount, and you want the interest to be calculated less often. Because the more you're calculating interest on your loan, the more you're going to have to end up paying, right? Now, when you're talking about an investment, you want a high interest rate. And you want a large amount of principal, because then you're going to be making interest on that large amount that's being invested. And you want the interest to be calculated more often. Okay, so those are some principles. So if we move on to the next page, which of the factors below would increase our investment? Would increasing the amount invested in the beginning, is that going to increase our investment? Sorry, so it says here, so the factors below that would increase our investment. Okay, so again, increasing the amount that we invest in the beginning, in other words, the principal, a larger principal is going to mean we're going to have more investment in the end. And then having the interest calculated more often, so if it's calculated weekly versus monthly, that's going to increase the amount of investment we're going to have in the end. And then increasing the interest rate, again, is going to increase our investment. And so based on that, which of the following would not speed up the growth of an investment? Okay, so look over there, the different possibilities, 4 possibilities, and decide which one is not going to speed up the growth of the initial investment. Okay, so is increasing the initial investment, decreasing the interest rate, having the interest compounded semi-annually rather than annually, or increasing the interest rate? Okay, on to the next one. This question here, the numbers don't come out that clearly on the graph, so I wrote them here. Okay, so those are the different percentages for different parts of the budget. And it says that the Taylor family has consulted with a financial planner to help them balance their expenditures. It says that their net income is $46,200 per year. Now the question says the maximum monthly amount they could afford to pay for housing and utilities. So first notice that it's a monthly amount. Okay, we're given the amount here of their net income as a yearly amount. We need to find the monthly amount, and it's going to be in the area of housing and utilities. Okay, so we would look on the graph and we would see that housing and utilities is 30% of whatever he makes, or rather whatever the Taylor family make per year, the $46,200. So 30% of that is going to be for housing and utilities. So it's 30% of the yearly net income, which we know is $46,200. Now we can't multiply 30% times that number. We need to change it into a decimal. We do that because 30 divided by 100 gives us 0.3. So 0.3 times 46,200. So that's going to be the amount that they can spend on housing and utilities. So we would calculate and find out what this amount is. Once we do, we divide by 12 because the question is talking about the maximum monthly amount the Taylors could afford. Okay, so that's all there is to that question. Going on to the next one, we've got a expensive looking stereo system here. And the question says Duncan bought a stereo system for $1,290. He put down 15% of that amount first, and then he agreed to pay the remaining balance by paying 12 monthly installments of $110. So overall, of course, he's going to pay more than the $1,290 because he's getting to spread that out over a year. So how much is Duncan paying in all? What's the total cost of the stereo? It's going to be the down payment amount plus the balance owing. So the down payment amount, again, is 15% of $1,290. The way we find that, 15% is 15 over 100, which comes to 0.15 as a decimal. We multiply 0.15 times $1,290. That's going to give us the down payment amount. How much is the balance owing? Again, the question says it's paying 12 monthly installments of $110. So that's going to be 110 times 12. Okay? So we add together the down payment amount, which we calculate this way, plus the balance owing, which we calculate this way, and that's going to find the total cost of the stereo. Okay, we got a little picture of Albert Einstein, and you know, you would think that he would think that the most powerful force in the world, in the universe, was the nuclear force, but he says that it's compound interest. And again, that's because compound interest is interest on your interest. So it is really a powerful force because it allows you to accumulate money a lot more quickly by getting interest on your interest. So it's great to get compound interest when you have an investment. Okay, so the next question deals with compound interest. It tells us that we're investing $1,500, and it asks us how much is it going to be worth if it's invested for 6.5 years at 5.2% a year, compounded semi-annually. Okay, so we use this formula, and we need to know how to use this formula, be familiar with it. There'll be a formula sheet that's going to be on your midterm exam. And so here are the different parts of it. So A is the amount we're calculating. Okay, so that's what the question's asking. What's the amount of money, how much money is $1,500 going to be worth after you compound it? Okay, so we're trying to find what A is. That's the amount that his investment is going to be worth. So what we do is we start with P, which is principal, and that's $1,500. That's the amount invested. Okay, so that's going to go in there in the formula. And then it's 1 plus I over C. Okay, I is the interest rate per year. We're told in the question that's 5.2%. But when we deal with this type of formula, we need to put it as a decimal. So 5.2 divided by 100 is 0.052. That's the interest rate per year. But we're not compounding it yearly. We're compounding it semi-annually, twice a year. So we divide this amount by 2. You can see we're dividing it by 2. Okay, so it's the interest rate per year divided by the number of compounding periods, which is 2 a year. Okay, and then we also raise this to the exponent n times c. N is the number of years. We're told it's 6.5 years. We multiply that 6.5 times 2 because we're compounding the interest twice a year. Okay, so make sure you understand what each part of the formula represents so that you can use this formula and use the different information given in the question to plug it in and find what A is. Okay, so what we do then is 0.052 divided by 2 is 0.026, and we're going to add that to 1. So then when we get this number, which is going to be 1.026, we're going to raise that to the exponent 13. So we're going to use the x to the y button on your calculator, and we're going to take 1.026, press the x to the y button, press 13, we'll get a number. Then that number is multiplied by 1,500, and that's going to give us the amount the investment is worth. Okay, so really important formula on compound interest. Okay, so we're going to shift gears, and most of the midterm exam is not on the investment and budget stuff because that was covered on test 1. So that's what we're going to talk about at this point. So this question here says, when the furnace shuts off every night in a local bank, excuse me, the temperature drops at a constant rate from 22 Celsius to 16 over the course of 4 hours. It says the rate of change of temperature with respect to time is. Now when you talk about the rate of change of temperature, that's like speed. Whenever you're talking about rates, it's kind of another word for speed. So we're talking about change of temperature with respect to time. So we have two things that are involved: change in temperature and change in time. So that's what we're going to use to calculate the formula. Okay, and I'm going to jump to that here. The way we do it is it's final temperature minus initial temperature. Whenever you're talking about a change in something, it's the final something minus the initial something. So the change in temperature is final temperature minus initial temperature. And you divide that by the final time minus the initial time. So we're told in the question that the temperature started at 22 and then it goes to 16. Okay? So final minus initial is 16 minus 22. And that's going to give us a negative value, right? You can see it's going to be minus 6. Okay, so the change in temperature is going to be minus 6. The change in time is final time minus initial time, which was 0 hours. Okay, so you can see that's going to be 4 hours. So we're going to take this amount and divide by this amount, and that's going to give us the rate of change of temperature with respect to time. Okay? So again, remember when we're talking about a rate of change, it's kind of like speed. It's how fast one unit changes compared to another unit. And if you think about something like kilometers per hour, that's the change in distance divided by the change in time. Okay, so you can see that this is the way we're going to calculate this question, and you would then just have to plug that in on your calculator. Okay, awesome. So let's go to the next question. It says, which of the following diagrams best represents a ramp with a 2 to 4 slope? Now, if you see the slope written in that sort of a way, remember slope is always rise divided by run, or how high divided by how far along horizontally. Okay, so this basically means the rise is 2 and the run is 9. Okay, so which one of these represents a rise of 9 and a run of 9? Sorry, a rise of 2 and a run of 9. Okay, well, think of it this way. If we take each one of these diagrams, if we divide 4 by 18, what do we get as a decimal? Okay, That's one way of doing it. And we can find out what that is as a decimal. If it's the same thing as 2 divided by 9, we're going to have the same answer. Another way of thinking of it is this diagram here, where we have 4 and 18. This represents 4 to 18. Okay? This one here, the rise is 18, the run is 4, so we can write it as this way, 18 to 4. This one, rise 6, run 27, we can write it this way. The last one you'll notice, the rise is infinite. It's infinitely high, so we make it infinity to 27. I know that sounds weird. So another way of doing this is to reduce these ratios and see which one of them gives us the same ratio as 2 to 9. Okay, so in other words, we would have to divide the same number into one of these ratios and get 2 to 9. So whether it's 2 that we divide into both numbers or 3, whichever one gives us 2 to 9 is going to be the right answer. Okay. So on to the next question. It says, use the info provided in the graph to answer the question. So we're driving from point A to point B. You can see we have distance on this axis, time on this axis. The question says, how far was the car traveling between 50 and 60 minutes? So this is the part that we're interested in right here. Okay, so how far was the car traveling? Sorry, it says how fast was the car traveling. And we know that we get the speed, when we have a distance versus time graph, the speed is really equal to the slope of the graph. Okay? So we divide the distance by the time. Okay, so between 50 and 60 minutes, we divide the distance by the time to find the speed. Okay, so we find distance. You can see if you go from this part of this interval, 50 to 60 minutes, goes to 125, this part goes to 75. Okay? So the distance traveled between 50 and 60 minutes is 125 minus 75 kilometers. If you do that on your calculator, you'll find that's equal to 50 kilometers. So that's distance. Then we divide that by the time. How much time is that? That's 10 minutes, right? Okay? So it's 50 kilometers divided by 10 minutes. Now, let's say this question gave us answers in kilometers per hour, and we have 50 kilometers per 10 minutes. Well, 1 hour is 60 minutes, right? So we would multiply both the 10 and the 50 by 60, and that would give us kilometers per hour. So it's good to know how to be able to do that. If you get kilometers per minute, know how to be able to change that into kilometers per hour by multiplying by 60. Okay, next question. We're going to talk about the difference between the slope of a horizontal line and the slope of a vertical line. Now, a horizontal line has zero slope, right? If you saw that as a ski hill, you would say it's got no slope. Okay, so horizontal line, no slope. Vertical line is infinite slope. It's infinitely sloped, right? Another way of saying it is that its slope is undefined. So with our question here, the question says the slope of a driveway with no rise. Okay, so think about what rise looks like. Is this one going to have no rise, or is this one going to have no rise? Right? It's going to be this one, right? It has no rise. So what is its slope going to be? Okay? So remember, slope is equal to rise over run. And in a situation like this here, the slope is 0, or rather the rise is 0. The run could be 5. We don't know what it is, but let's say it's 5. So it's 0 divided by 5. 0 divided by 5 would be 0, right? Okay? Because you can divide 0 by a number. It's going to give you 0. On the other hand, you can't divide by 0. Dividing by 0 is not allowed in math. So sometimes people get that mixed up. They think, okay, how does that work? Am I allowed to divide 0 by a number? Is that okay? Or is that not allowed? can I divide a number by 0? One way of helping you to remember that is, remember this. Divide by 0? No, can't do it. Okay, so think of this as like a 0, but it's really an O. Okay, so divide by 0? No. 0 divided by something else? Okay. Okay, so that's kind of like a 0 divided by some number. That's okay. You can do it. But you can't divide something by 0. Okay, divide by 0? No. Divide 0 by something else? Okay. All right? So if you just remember the rule, you cannot divide by 0. If you get that kind of ringing in your mind, that's another way to remember it. If you remember you cannot divide by 0, then you can remember, okay, but I can divide 0 by something else. Okay, so again, in this situation, we had a slope of a driveway with no rise. So it's like rise over run. It's like 0 divided by the run. Yeah, we can do that. We can divide 0 by another number. So that's why the slope was 0. Okay. So, dividing 0 by a number is okay. But dividing another number by 0 is a no-no. Undefined, or infinity. Okay, question number 10. Use the info provided in the graph to answer this question. It says, what happened between 10 and 20 minutes? Okay, well, what does the slope of the line look like? What kind of number would you get for this kind of a slope? Okay, well, remember, when we're talking about what the speed was like between 10 and 20 minutes, if we're trying to find the slope of this line, because remember the slope of this line is going to give you the speed, right? Because that's distance, rise over run, distance over time gives us speed, okay? So, between 10 and 20 minutes, what's the distance traveled? It's nothing. The distance is not going up at all. Distance is 0. Time is 10 minutes. So the speed is 0 distance divided by 10 minutes. What's that going to give you as a number? Okay? So when you think about what number that's going to give you, relate it to the different possible answers. Was the car stopped? Was it traveling at a speed of 25 kilometers an hour? 2.5 kilometers an hour? Okay? So again, relate this to the 4 possible answers. All right. So, question 11. John walks 10 meters towards a motion sensor over the course of 30 seconds at a constant speed. What would the slope of the segment representing this walk on a distance versus time graph? Okay, so we need to figure out what the slope would be. Well, this is what the graph's going to look like. It's going to be a distance versus time graph. Because it's a constant speed, you have a straight line for constant speed, right? And the question says, what would the slope be? Well, the slope is going to be rise over run to find this slope. Rise is distance, that's 10 meters. Run is 30 seconds. So it's going to be 10 divided by 30. Okay? So 10 divided by 30. Now, we might have a situation where we have possible answers in lower fractions, like maybe 1/2, 1/4, 1/3. And we would have to reduce 10 over 30 to find out what the answer would be in lowest terms. So we just need to divide the same number into both top and bottom. All right, so going on to the next question. The next question says, a roof with a pitch of 9-4 is one of these possibilities. And remember, when you have a pitch of 9-4, that's another way of saying the slope. So the slope of a 9-4 pitch, what does that mean? Well, again, remember the first number is like the rise, and the second number is like the run. So slope is equal to rise over run. So this is like 9 divided by 4. And we could do that on our calculator, and we would get 2.24. Okay? So a pitch of 9-4 gives us a slope of 2.24. because of the fact that this is the rise number and this is the run, and so we can divide 9 by 4 to get 2.24. So, if you think about it, the greater the run, the higher the slope is going to be, right? So something like a 10 to 4 is going to have a higher slope, okay, because the run number is larger. So 10 divided by 4 is greater than 9 divided by 4. So here it is written out, 10 to 4 pitch is greater than a 9 to 4 pitch. Okay, so when we do the math, that gives us 2.5 being greater than 2.24. So again, it makes sense because the run was greater, the slope is going to turn out to be greater. So with that in mind, in this situation, you're comparing a 9 to 4 pitch with these other pitches. And so, you know, for instance, it gives you different possibilities, like it's saying the 9 to 4 pitch is steeper than a roof with a 10 to 4 pitch. Is that true? Well, if it was steeper, the slope would be greater. So we would find what's this slope as a decimal, what's this slope as a decimal, and then we could figure out if this statement is true. Same thing with B. Is a 9 to 4 pitch flatter than this roof? Well, again, we would need to find out what's the slope here and what's the slope here. A flatter slope is going to have a smaller number, right? So you can make these comparisons, but remember, take this 9 to 4 number, make it into a decimal, considering the fact that we know that slope is rise divided by run, so we can get that decimal, which was 2.24 here. Okay, so that's how you can make these comparisons between the numbers and see which of these answers is right. So again, remember, pitch is just a different way of telling us what the slope is. It's giving it as a ratio. Okay, question 13 says use the info provided in the graph to answer the question. And it says, during which time interval was the jogger the slowest, going the slowest? Well, we know that the slowest speed is going to be the flattest slope, right? So we want to look for the flattest slope. So which interval gives us the flattest slope? Well, here are the different time intervals. 10 to 4, does that look like the flattest slope? Slowest speed? How about this? Is that the flattest slope? This here or this here? Well, it makes sense that it's this one here. It looks similar to what follows, but it looks like the slope increases at this point. So this would be the flattest slope. That's the slowest speed. Okay? If you weren't sure, if you weren't just trying to guess, you could do the calculation, because the speed is going to be, again, it's the same thing as the slope. So we could divide the rise by the run. See here we're dividing 0.5 by 10. We could do that and come up with a decimal. Do the same thing for this time interval, and this time interval. And whichever gave us the smallest number is going to be the slowest speed. Now it's a little more difficult to do when you're talking about these ones here. So that's where it helps just to know the fact that slowest speed is going to be flattest section of the graph, and so we don't actually have to do the calculations. Okay, next question. It says, which of the following graphs best represents the motion of a car that keeps speeding up? Let's analyze each one of these. And there's A here, B here, and then we're going to look on the next page for C and D. This graph here, we have a certain rise over a certain run, and that's going to give us a constant speed, constant slope. So here the speed is constant. Here we're going to have a certain rise, which is 0 over the run. 0 divided by run, we know that equals 0. So the slope is 0, the speed is 0. So whatever is traveling, whether it's a car or a bike, it's stopped in this situation here. Speed is stopped. This situation here, you can see it's the speed's going up, it's stopping, it's going up again, it's stopping, going up more. Okay, remember what the question asked us. Which one of the possibilities is one where the car keeps speeding up? That's going to be possibility number 4, because we can see that the speed increases, right? The slope is here, and then it goes up, so the speed, which is the slope, is increasing, and the speed, which is the slope, is increasing again. So the speed is going up and up. Okay, question 15. It says if 2,496 people enter the home and renovation show at a constant rate over the course of 8 hours, then the rate of change of people is how much? Okay, so rate of change of people, basically it's the rate of change with respect to time, right? Okay, so it's the change of people. What's the change? It's 2,496. So that's the change in people. What's the change in time? 8 hours. So we divide this 2,496 by 8. We're going to get a number. Whatever that number is going to be, we're going to have so many people per hour, right? That's going to be our answer. All right, so on to question 16. It says a 2.6 meter ladder is leaning against a building with its base 0.8 meters away from the building's wall. Whenever you see something like that and it's asking for the slope of the ladder, we know we're going to have to draw a diagram to figure out what's going on. So we're wanting to find the slope, that's what we're after. So we draw a diagram. When we draw our diagram, here's what the situation looks like. We're told that the ladder was 2.6 meters. So here's the ladder. You could draw an actual ladder if it helps you to kind of get a better picture of what's going on. It says the bottom of the ladder is 0.8 meters away from the building. So we need to find the slope. We know that slope is rise over run. We don't know what rise is. Rise is the height of the wall, but we don't know what that is. We're going to have to use the other information given to find out what that is. What we do know is we're told what the slope is. Or sorry, we're not told what the slope is. We're trying to find the slope. But again, in order to find the slope, we need to find the height, because then we can find rise and divide it by run. So first we need to find rise. Then we can divide it by run and find slope. Okay, so let's find the height of the building. So how are we going to do that? Well, we know it's a right angle triangle, and we know we're given the longest side, so we can use that and the length of the short side here to find the length of the other short side. We know that the way the formula is set up, the Pythagorean formula, is long side squared equals short side squared plus short side squared. Okay? So here it is written like that. Long side squared, 2.6 squared, is equal to short side squared plus other short side squared. That's the one we're trying to find, h. Okay? So here's how we set up the problem, and we need to find h by the time we're done. 2.6 squared, we can find that on our calculator. It's this much. 0.8 squared is this much. And now we have the formula like this. Now we want to find what h squared is, and we have this 0.64 on the same side of the equation. So we need to get rid of the 0.64. We do the opposite of plus 0.64, which is minus 0.64. So we subtract 0.64 from both sides of the equation. So we get h squared is equal to 6.76 minus 0.64. We're doing the minus 0.64 on the left side of the equation, but we don't show it. It just cancels out, and we're left with h squared. Okay, so we got this math on the right side of the equation. We do it, and then we end up with h squared equals 6.12. We need to find h, not h squared. So what's the opposite of h squared? That's finding the square root. So if we take the square root of both sides, we'll be able to find h, which is what we want. So we take the square root of h squared, and we're left with h, and then we take the square root of 6.12, and that equals this, 2.47. Okay, great. Now we know what the height of the building is, 2.47. Now can we find the slope? Yes, we can, because slope is equal to rise over run, and we know both the rise and the run, so we can find the slope. We can divide 2.47 by 0.8, and that will give us the slope. Okay? So again, we just need to figure out what do we need to find first. We need to find the height of the building, the rise. Once we found the rise, then we could use the slope formula. Again, it all starts off with a good diagram to help us kind of sort things out. Okay, question 17. A house construction crew purchases prefabricated roofing from a variety of suppliers. In one particularly snowy community, houses must have a roof with a steepness of at least 9 to 5. Okay, now we have these different possibilities, 4 different possibilities. The trick, though, is this steepness is given as 9 to 5. These slopes we're going to have to calculate. So how are we going to do that? How are we going to compare this 9 to 5 ratio we're given at the beginning to these here? Well, it's always going to come down to slope, isn't it? And we know that this is just another way of writing slope. We know that the 9 is the rise and the 5 is the run. So we can take that and find this as a decimal. And then we can find each one of these as a decimal. And then we can compare. And since we know that the house roof we're looking for has to have a slope of at least whatever 9 to 5 is as a decimal, that's the decimal we're looking for. We need to find at least that decimal. So now remember this. When we're finding the slope of these roofs, slope is rise over run. We just need to focus on one triangle, not the whole diagram, because rise is going to be the 6 feet, and the run is going to be half of 28, which is going to be 14. Because when we're looking at the slope, it's the slope of this line, right? We don't take into account this whole 28 feet. We're only dealing with 6 over 14 gives us this slope here, okay? So 6 over 14 gives us a slope of 0.43 as a decimal. And we're going to relate that to the decimal we get from 9 divided by 5. And we want to find out, is this slope as large as whatever this decimal is saying it should be? If it is, then that's the right roof. If not, we look at the next one. Whatever 8 divided by 18 is as a decimal, is that decimal large enough to be what this decimal is? Okay, so the only way to find out is to change each one of these, find out what each one of these slopes is, and find out what they are as a decimal. So which slope is at least 9 to 5 as a decimal? Just to make that a bit more clear on the next page, first of all, I wanted to mention, for this question here, the way the answers are given, A, B, C, D, that's not the order that they were originally on the last page. Okay, for instance, A is aim high roofing. Well, aim high roofing was number 4. Okay, so it's just important to recognize that sometimes the order that the answers are given in is a little bit different. Okay, so I just wrote that here. The options are not in the same order. Okay, so again, what we would do is change each one of these into a decimal and see which of those decimals is going to be the right number. So when we had a pitch of 9 to 5, again, slope equals rise over run. 9 divided by 5 is 1.8. Okay, that's the decimal we're looking for. So we need to find out which one of these is going to give us a decimal of at least 1.8. Then it's meeting the qualifications we're looking for. Okay, question number 18. Experts determined that the snow ramp at White Flake Ski Hill must have a slope. The snow ramp at White Flake Ski Hill must have a slope of 1/6 to allow skiers to safely get off the chairlift. If the height of the ramp is 0.8 meters, what is the length of the ramp that is skied on? Okay, again, you can tell that you're going to have to draw a diagram to solve this one. But what are we looking for? We're looking for the length of the ramp that is skied on. So when we draw our triangle, we can see that the question says the height of the ramp is 0.8, so we label that. And the question says that we're looking for the length of the ramp. So that's the part we label. That's the length of a ramp, right? Well, in order to find that length, we're going to have to find this x. And again, we're going to be dealing with slopes. This is the rise, this is the run. And we're going to somehow relate this rise and run to the fact that we're given a slope of 1/6. Then we'll be able to find this x, which is the short side of a triangle, right? A right angle triangle. And then we can use length squared is equal to x squared plus 0.8 squared, and we'll be able to find what the length of this ramp is. So again, first job is to find this x, in other words, the run. Second job is to find the length. Okay, so let's find the run. See how we find that. Okay, so again, we know that the slope we're given of 1/6 is going to help us find that. Okay, so how we find x using the slope of 1/6? Well, we know that slope is rise over run, so its slope is 0.8 over x. So rise over run equals 0.8 over x. Well, we're told the slope is 1/6. So we write slope equals 1/6 equals rise over run equals 0.8 over x. So basically we're relating the slope of 1/6 that we're given to these values of 0.8, which is the rise over the run of x. So 1/6 equals 0.8 over x. That will help us to find x because we have a proportion. There's different ways we could find out what x is. The easiest way is when you have a proportion, two fractions equal to one another, you multiply the top of one fraction by the bottom of the other. So 1 times x, that's shown right here, is equal to, again, top times bottom, 6 times 0.8. 1 times x gives us x on the left side. 6 times 0.8 gives us 4.8. So we found out what x is. That's great. So we now know that x is 4.8, and we can label that right here, 4.8. And now we can use the Pythagorean formula. So length squared, or in other words, long side squared is equal to short side squared plus short side squared. So length squared is equal to 0.8 squared plus 4.8 squared. And we see that math on the next page. Okay. So this here is basically, we said c squared is equal to b squared plus a squared. This is basically long side squared. In other words, the length of the ramp is equal to the short side squared plus other short side squared. We find out what these squared numbers are, and we have the length of the ramp squared is equal to this number plus this number. We add them together. Okay, so again, length of ramp squared equals this number. How do we find the length of the ramp? We take the square root of both sides. That'll give us the length of c. When we take the square root of 23.68, we're going to find a certain number, and that's going to be the length of the ramp. And we're done. Okay, next question. It says, use the info provided to answer the question, what is the employee's regular hourly rate of pay? Okay, when we think about what that means, hourly rate of pay, it means you're getting a certain pay per hour, which is what the answers look like, right? A certain pay per hour. In other words, we're dividing income by hours worked. So we're dividing income by hours worked. Okay, so we're looking for the regular hourly rate of pay. Well, that's going to be, since we have a certain rate of pay here, and then this is a larger rate of pay, right? The graph is more steep. So you're making more dollars per hour in the second section than you were in the first. What that tells us is that this is basically regular rate of pay here, and this is overtime pay here, right? So we're looking at the first section of the graph, And when we want to know what the rate of pay is, well, the rate of pay is, again, the slope of the graph, which is the rise. Okay, what is the rise here? Well, if we run this part of the graph over to here, we can see that's going to be 600 because each section is 200. Okay, 600 divided by 40. All right, and we can do that on our calculator. So $600 divided by 40 hours, and we'll get a certain answer, one of these possibilities. But again, remember, a rate is like a slope. So as soon as you see that question and you see that you're looking for a rate of pay, you think, okay, I'm trying to find a slope, because rate is always like slope. Or it's also like speed. Okay, question 20. The slope will be undefined for which of the following components of a house? Okay, so we're thinking about different surfaces in a house. Remember, an undefined slope is like an infinite slope. Remember, if you have a flat line, you have a zero slope. If you have a vertical line, you have an infinite slope. It's infinitely sloped. It's also an undefined slope. Okay, because remember, it's a rise, which is infinity large, divided by a run. And there's no run at all. The run is zero. We're dividing by zero, which is undefined. Okay, that's why the slope is undefined. Okay, so think about which of these possibilities gives us an undefined slope. Which one of these situations looks like this undefined slope here? A roof, a driveway, garage, pad, or a kitchen wall? Okay, remember this to help you out. Divide by zero? No, we can't do it. Zero divided by something else? Yes, that's okay. Okay, the next question says Sarah walks her dog. In the first 10 minutes she walks 1 kilometer, and she walks this many kilometers in the next 4 minutes. Okay, so it's walking a different amount in different minutes. It says during which interval of time is there the greatest rate of change of distance with respect to time? Remember, the rate of change of distance with respect to time is another way of talking about the speed. Okay, so which is the greatest speed? Well, we know we're dealing with distance and time, and speed is equal to distance divided by time. So we can just do the calculation and find out what the speed is by dividing distance by time for each one of these intervals. Okay, so we would divide this distance by this time and find what that is as a number on your calculator. Divide this distance by this time. So we do the calculation for each time interval and find which speed gives us the greatest speed. All right. Again, remember guys, really important to practice all these questions on your own so you can make sure you're getting them. So, question number 12 says a skateboarding ramp is 12 feet long as shown. Okay, so the ramp is 12 feet long. It says what is the slope of the ramp? Well, we know that slope is rise over run. And I labeled the rise here. If it wasn't labeled, you could label it there and that would help. Okay, so the slope is the rise over the run. And so we need to find what the rise is, and then we can find the slope. Okay, so let's find out what y is going to be. So y needs to be calculated, then we can find the slope, rise over run. So how are we going to find what y is? We're going to have to use the Pythagorean formula, because long side squared plus short side squared equals other shorts. Long side squared plus short side squared. Long side squared is equal to short side squared plus other short side squared. Sorry guys, I got a little confused on that. So let's see it in the calculations. Okay, now on this question here, you could do it that way. You could say 12 squared is equal to y squared plus 11.59 squared. But what we're going to do as well is we can also use the trig functions. Okay, since we're given an angle of 15 degrees, we can use that to help us find what y is. Okay, so let's think about trig. We know with trig we have SOHCAHTOA. Okay, Now, the y is opposite to 15 degrees, and we know we've also got the 12 degrees. So, opposite divided by hypotenuse. Okay, so opposite divided by hypotenuse is sine, right? Sine equals opposite divided by hypotenuse. Okay, so the sine of 15 degrees is going to be equal to opposite divided by hypotenuse. So sine 15 degrees, we write that down, is equal to opposite divided by hypotenuse. In other words, y over 12. So we write down sine 15 degrees equals y over 12. We need to find what y is. Okay, if we want to find what y is, since y is divided by 12, if we multiply by 12, we'll get rid of the divided by 12. So we multiply both sides of the equation by 12. Okay, so sine 15 times 12 is going to give us y. So to find out what this is on our calculator, we press 15, then we press sine, we multiply that amount by 12, and that's going to give us what y is. So now we found what y is. Okay, and so we found what the rise is, we know what the run is. The question is asking us for the slope. Slope is going to be this amount, which was, what was it, 3.11. Okay, so slope is going to be 3.11. In other words, the rise divided by the run of 11.59. That's going to give us a decimal, so one of these possible answers. Okay, next question. During which interval of time was the speed the slowest? Okay, well, we know we're talking about distance divided by time for the speed, and we know that the speed is the same as the slope of the line. In other words, during which interval do we have the smallest slope, or the flattest slope? Well, you can pretty much tell by looking at this that it's either going to be this interval or this interval. And to find out which is the smallest slope, you can divide rise by run, and then you can find which has the smallest slope. Okay, so one of these time intervals, either this one is going to be the smallest slope, or this one, or this one, or this one. Okay, so next question. It says the slope could be determined for all the following except. So a tightrope, a Ferris wheel, a concert stage, an amusement park, line ramp. So when we studied slope, we know there's certain types of surfaces we can find the slope of and certain types we can't find the slope of. So which one of these looks like one that we've never really looked at before as far as its shape? Tightrope, Ferris wheel, concert stage, or amusement park line ramp. Okay, last question. This question here is going to be similar to the one we looked at earlier. Earlier we looked at different factors that improve an investment or make it worse. Now we're looking at a mortgage. So which of the following is not going to help us pay down a mortgage faster? Now a mortgage is a type of loan, right? And so considering that, think about which types of things are going to help us to pay a loan faster. Now, I think this page is one we can ignore, actually. That shouldn't relate to this information here. So we'll go to the next page. Okay, which of the following is not going to help us pay down a mortgage faster? So we'll look at possibility A. If we increase the deposit, so the deposit you put down in the beginning, if we increase the deposit, is that going to help us pay down a mortgage faster? Increasing the deposit means less money is being loaned, so less total interest is going to be paid. So is that going to help us pay down the mortgage faster? Well, how about making more frequent payments? B. So if we make weekly payments on the mortgage instead of monthly payments, is that going to help us pay it down more quickly? Well, the more often we pay down our mortgage, the less interest we're going to pay in the end, right? Our mortgage is going to be paid down more quickly, so less interest overall. Now, Also possibility D, increasing the amount of each payment. So larger monthly loan payments, again, means that the mortgage is paid more quickly. But possibility C, increasing the interest rate, is that going to help us to pay our mortgage down more quickly? If the monthly or weekly interest that we pay on the mortgage is going to be increased, is that going to help us pay the mortgage down more quickly? No, it's not. All right, so guys, I hope this helped with understanding these questions. If there are any that you try after watching this recording and you're not sure how to do them, please send me an email. But again, please watch the recording, make sure you're understanding it as you're watching it, then practice the questions and make sure you can get each one of the questions on your own after watching the recording. So again, the questions on the midterm exam are going to be really similar to these, and that's going to be on April 16th. Hope things go well with your studying. Have a great day, and God bless. Bye for now.